So today we're going to start off with section 4.1, the vertex form of a quadratic function. Before the recording started, I had mentioned how there's two forms for quadratic functions. There's vertex form and standard form. So today we're doing vertex form. Monday we will do standard form. But vertex form looks very similar to the absolute value function's standard form, right? Or I guess you could call it its vertex form as well. But the only difference is that we have parentheses with a square at the end instead of the two absolute value symbols, right? But I had already pre-written everything because it's basically just a repeat of what we've learned from before. So we learned before that our A term tells us whether it opens up or if it opens down. And then we also know that our A term is considered our slope. Now, I put the word slope in quotes, okay, because of the fact that it's not really the slope constantly. It's not the same slope all the time, but it is the slope initially, the first time you do it, okay? So I'm going to kind of put that right here. Let me just put it right here. First time, okay? Because after that, let's say the value of A is 2. Oh, it's frozen. Let me make sure. Where did I leave the thing? Here it is. So I'm going to put right there, right next to slope, I put first time. So let's pretend that A is equal to 2. That means once you put your vertex on your graph, you're supposed to do, if A is 2, you can go 2 up, 1 over in both directions. 2 up, 1 to the left, 2 up, 1 to the right. But the next time it's actually supposed to be 4 up, 1 to the right, 4 up, 1 to the left from each point. So, but that gets a little bit more confusing because it changes every time. The second step becomes squared. The third step becomes squared again. So, so I don't like to really kind of go that far. So what I'm going to do is we're just going to use the slope the first time, and then from there we can draw it. So it kind of keeps it easier for us to do the work. Okay? You'll see it once we start working on the actual graphs. And then our H term, it says, again, if it looks negative, that means it's really positive, so go right. If it looks positive, that means it's really negative, so go left. The K term, if it is positive, go up, and if it's negative, go down. And we know that H comma K is our vertex for the absolute value and also for this, okay? Now, so far we understand this part from previous knowledge, right? Stuff we've done from other work from before. Now let me introduce a couple of little things that are going to be new, okay? So, if A is positive, then HK is a minimum, okay? So the vertex is a minimum, meaning the vertex is the lowest point of the graph. So if A is positive, the vertex is a minimum. HK is a minimum. There's going to be some problems on your homework where they're going to do that. They're going to tell you like, all right, here's an equation of a graph. Tell me whether the vertex is a maximum or a minimum. And all you have to do is look at your A term. And if your A term is positive, you're going to say, okay, it opens up. That means the vertex is way at the bottom. So it's a minimum value. Okay. The other part is if A is negative, then HK is a maximum. And right now I'm going to draw you guys real small pictures here. But let me show you what I'm talking about. So if A is positive, your graph is supposed to look like this. Okay? The vertex will be at the very bottom right there. That's why they say the vertex is a minimum. Okay? So if A is positive, HK is a minimum because the graph would be opening up, so the vertex would be at the very bottom. So we say it's a minimum. Okay? Now if A is negative, the graph is going to look something like that. Not necessarily that wide, but it's okay. But the vertex will be at the very top. That means it's going to be a maximum value. It's going to be at the very top of that graph. Okay? So if A is positive, HK is a minimum. Your vertex is a minimum. If A is negative, HK is a maximum. All right? So does that make sense? Since it's opening down, it has a high point. Since it's opening up, it'll have a low point, right? So max and mins are based on that. Now, there's one other thing I got to talk to you guys about, which is the axis of symmetry, okay? So what is the axis of symmetry? And then after that, we can start doing some examples that relate to your homework. So the axis of symmetry. Now, it's just a formula, okay? Well, not really a formula in this case, but it isn't. It's not a big formula. X is equal to H. That's it. That's your axis of symmetry, okay? So if H is a positive 3, you're going to write X equals 3. If H is a negative 1, you'll write X equal to negative 1, okay? What is the axis of symmetry? Well, I'll draw a little picture for you guys. Every parabola can be cut in the middle. Now, forgive me if my line isn't perfect, but there's this invisible line that cuts the parabola in such a way that the left side and the right side are perfect replicas of each other. They're just flipped. So the axis of symmetry here would look something like this. This would be your AOS. You'll see me write that down. AOS, axis of symmetry. Okay, which we defined as X equal to H. So whatever the H is, that's your axis of symmetry. So they ask you like, okay, you got this formula here. What's the axis of symmetry? Just ask yourself, what is H? Whatever H is, the actual value of H, that's your axis of symmetry. X equal to 3, X equal to negative 5, whatever it happens to be. That's an invisible line that cuts the parabola in half, vertically in half. Okay? So we've gone over everything you need to know to do the homework for today. The only thing we haven't gone over is the graphing portion, but we'll get to that. Okay? But just a real quick review, that way we can kind of take in everything again that's happened. Remember, we have our vertex form, y equal to a times x minus h quantity squared plus k. I'm bringing this with me because I want the mic close to me. It looks like the absolute value function, just that this is different right here, right? The parentheses and the squared. A term opens up if it's positive, opens down if it's negative, and we call it our slope with the little quotes on it because it's not really the slope all the time, but it is the slope the first time you apply it. Okay, not always, because if you always do that same slope, you end up with an absolute value. Absolute values always use the same exact number to find the next point and the next point and the next point. Parabolas will only use it once, okay? So only the first time. Then we said H, well, if it looks negative, go to the right. If it looks positive, go to the left. We know that already. K, if it is positive, go up. If it is negative, go down. Again, we know that already. And we also know that HK is a vertex, okay? And then we started to introduce a couple of new things right here. If A is positive, the graph is going to open up. Okay, it looks like kind of like a U shape, a little more V shape, but not so sharp like a V. So it's kind of like a U shape graph. If it's opening up, the very lowest term is going to be our vertex, and we're going to say it's a minimum. Okay, we're going to tell them that it's a minimum. If A is negative, that means the graph is opening down, which means that the highest point is going to be considered our maximum. Okay, the vertex will either always be a max or a min, one or the other. Okay, it just depends on the graph. All right, but the vertex is either going to be a maximum or a minimum depending on your A term. You don't have to calculate anything, just look at your equation. Okay, and from there you can tell me if it opens up or if it opens down. All right, and then the last thing that we discussed was the axis of symmetry, which this is the very easiest formula for axis of symmetry in terms of vertex form. When we talk about it on Monday, it's actually x equal to negative b over 2a. That's that formula. But that's a whole different equation. But for this equation that we're using, the axis of symmetry is just x equal to h, whatever h happens to be. And here's just a real quick picture of what it looks like. It's an invisible line, like, yes, I can actually draw it, right? But it's an invisible line, a vertical line, that cuts your parabola in half vertically, okay? So it's basically a reflection of each other if you were to kind of look at it, right? They kind of reflect each other. So before I move on, does anybody have any questions on any of the definitions? All right, so let's talk about your homework. Now, on your homework, unfortunately, when they made the copies for me, when they sent them out, there were 4 problems that already had answers on them. I'm still going to cover them, but you're just not going to have to do them. Okay? I would recommend you look at them and just make sure you would have gotten that same answer. So basically, there's 16 problems on your homework. 4 of them were done by the computer, accidentally. Okay? So the rest of them don't have answers, but 4 of them do. So my bad on that. I didn't notice it, and I saw it later. But here we go. Here's the first example. Okay. The instruction is the vertex a maximum or minimum? Honestly, I think you guys won't mind this. I know it looks like it's a lot of work, but I don't think you're going to mind it that much because you already have enough practice from the absolute value stuff, so most of this should look very familiar. All right? So is the vertex a maximum or a minimum? So here's the first one. Y equal to 1/2 times x minus 3 squared plus 5. And the second one, I'm going to put y equal to negative 3 times x plus 2 squared minus 4. And I know I didn't ask for this, but I am going to ask you guys for this. First off, I want to know what the vertex is. Okay, then we can answer the question. Okay, I first want to know what is the vertex, because that'll help us not do an extra set of examples. We can kill 2 birds with 1 stone here. So for part A, can anybody tell me what the vertex is? Negative 3, 5 or 3, 5? 3, 5. Remember, H lies, right? So 3, 5. Don't forget, even with this formula, H still lies to you. Okay? So, all right, the vertex is 3, 5. Great. Now, is this a maximum vertex or a minimum vertex? It's a minimum because according to A, which is half, I'm going to kind of write it down, okay? Since A equals half, it opens up, right? So I'm going to say vertex is a minimum. I'm kind of wordy there. You do not have to write all that stuff out. I'm just, for note purposes, in case somebody's not here and they're looking later. That way they see the explanation, right? So since A is positive, that means it opens up. And if it opens up, that means the vertex is at the very bottom. Okay? So it's a minimum. All right, so what about part B? What's my vertex for part B? All right, -2, -4. All right. And is this vertex a maximum or a minimum? It is a max because A is negative, right? So I'm just going to write since A is -3, it opens down. Again, not something you have to write. I'm just putting that for note purposes. So vertex is a maximum. So when I said I want to kill 2 birds with 1 stone, the reason why I'm saying that is because there's going to be some problems on your homework where they're going to say, is a vertex a max or a min? All right, you just got to tell them max or min. But then there's going to be other problems where they say, what's the vertex? Right? So we did both. All right, so I helped us lose like 2 problems for extra examples. So as long as you can do this, you're good for like 2 sets of homework problems there. All right? Now, example number 2. let's find the axis of symmetry for a couple of these. So example number 2. What is the axis of symmetry for the function? So what is the axis of symmetry for the function? I'll give us 2 here. A y equal to 3/4 absolute value of x plus 1 quantity squared minus 6. And b, by the way, none of these problems are from your homework. Okay, the ones I'm doing right now, none of these are so far. And the reason is because I think personally they're easy enough where I don't want to take them away from you. Just some examples, you can do them real quickly yourself, so it's not going to take you a long time. Right, so if you have right here, what is the axis of symmetry for the function? I'm giving you 2 different functions here. Okay, what is the formula for the axis of symmetry? It's x equals h, right? What is h for part A? -1. So all you guys got to do is write this, and you're done. Okay, that's it. The axis of symmetry is always very easy with the vertex form. With the standard form, that's going to be Monday, there's a little formula you have to kind of figure out. It's a real tiny formula, but still, it's more work than this. What about the part B? X equal to -4. So how are we feeling so far? Easy, I think, right? Hopefully, not too bad. All right. So we took care of whether a vertex is max or min. We've took care of finding a vertex for one of these functions. We've taken care of finding the axis of symmetry for some of these functions. The 4 problems that you're not supposed to do because the computer wrote them down for you, I'm going to give you 2 examples just to kind of let you see what it was. And then from there, we'll move on to the graphing, and then we're done. And the graphing, there's like 8 problems you guys have to graph. Usually, some kids are like, oh man, I hate graphing parabolas. I'm not super picky with it. Some teachers will be like, well, in order to graph parabolas, you got to write down like 8 points, and then those 8 points, you got to figure them out, and then put dots everywhere, and then I just tell you, find the vertex, use your slope, right, to figure out 2 points. Then from there, just sketch it. Okay, so it's very quick the way I want you guys to do it. So here we go. Last one of these before we get into graphing. And this is going to be example number 3. So it says this. From the parent function, I'm going to kind of write it down the way they put it in your homework. Y equals x squared. Now, I'll stop just to explain this because a lot of times people, they get confused with this statement. From the parent function, y equals x squared. In other words, y equals x squared is called the parent because from y equals x squared, I can create any type of equation. I can write y equals x squared minus 5, y equals to parenthesis x minus 1 squared plus 2, y equals 1/2 parenthesis x plus 3 quantity squared minus 8. I can create so many different equations from the basic function, the parent function. I don't know if you guys have ever noticed, but I have a poster back there that's blue, and it literally says parent functions. In other words, the most basic types of functions. And from those, we can get every other type of function. Okay? So I guess you could say like the parent function is literally the parents, right? The mom or the dad of these other functions, right? So from the parent function y equals x squared, in other words, we're going to be using parabolas. That's what they're basically saying. Write an equation of the transformation. Remember, transformation means how it moves. Okay, you did that with absolute value. So write an equation of the transformation. Assume that a equals 1 for all examples. So in other words, they're telling you, look, A is always going to be 1, okay? Don't worry, A is always 1. So just assume that A is going to be 1. So I'm going to give you 2 examples for this. It's actually going to take us, I think, longer to write them down than to do anything else. So they're going to say translates 2 units right and 6 down. Okay, that's the first one. It translates 2 units right and 6 down. Remember, A is equal to 1. So I'm just going to write this out just for the sake of having it here. You don't have to do it if you don't want to. Remember, my habits as I got older and was in college and stuff, it helped me to always write down my formulas that I'm using. So they told me A is going to be 1, right? So that means Y equals 1. X, all right, well, it says 2 units to the right, so what do I put? Negative 2, so minus 2 squared, and 6 down, what do I write? Minus 6, and that's it. That's all you guys got to do. Notice you did that before with the absolute value, so this isn't brand new information. It's just a different way of writing it. All right, so here's one more, and then we'll move on to the graphing. So it translates 3 units left and 2 units up. It opens down. So it translates 3 units to the left, 2 units up, and it opens down. So I'm going to write down the formula again, just out of normal practice. All right, so what do I put for A? Negative 1. It's still a 1, but the down means it's negative, right? So negative 1. And then X what? Plus 3, quantity squared, and then plus 2. All right, and there you go. So these are the types of questions, the 4 questions that the program automatically wrote the answers for. It's numbers 9 through 12. You'll see them on your homework. It just wrote the answers there for you. So I guess I could tell you just check them, right? Make sure that that's what you would have written down. But you don't really have to do it if you don't want to. All right, are we okay so far? Because we're going to jump into the graphing part. We'll do 2 of those. I'll do 2 of them from your homework because there's 8 of them there. And then we'll be done with the lesson. But anything you guys need me to go over from the first 3 examples? All right, so here's example 4. And these are going to be from your homework, okay? So the instructions say sketch the graph. See, and for me, whenever they say the word sketch, that means it doesn't have to be perfect. It just has to be close. That's why I don't require you guys to do like 8 different points on a graph in order to graph it correctly. Okay? When you're doing a lot harder math and stuff, a lot of times they'll tell you to graph the function. Whenever they just say graph the function, to me that means like be a lot more accurate. But sketch just means like give me an overall idea of what it looks like. Okay? So here we go. So we'll start off with one that's a little bit on the easier side, and then we'll move on. Okay, well, I guess we can kind of do normal ones, but we'll see. So here's the first one. F of x is equal to, remember, f of x is the same as y, okay? So don't get scared when you see f of x. It's just y. If you want to rewrite it as y, go ahead. Okay? But just know f of x is basically just y. Where is my graph? All right, here we go. So I think I made a 5 by 5. Yeah, that's 5 to the right, 5 up. give you a couple seconds just to get that written out. This is number 5 from your homework, by the way. All right. In order to graph these, the first thing you want to do is graph your vertex. Where's your vertex? All right, but what is it? Negative 4, negative 4, right? So I'm going to go to negative 4, and I'm going to put a dot right there. Then you want to ask yourself, which way does it open? All right, so it opens down. All right, so I know my graph's going to open down. So according to this, my slope is what? Slope is negative 1. That means, well, I'm going to put negative 1 over 1. So from that vertex, I'm going to go once down, once to the right. And from the same vertex, once down, once to the left. And then I'm just going to draw my graph. And it's going to look like this. It's going to be curved, okay? Not straight lines, curved. And you're done. That's your graph. If this was an absolute value function, it would have looked like this. Like straight lines like that. But it's not. This is a quadratic, so it's going to be curved. Questions on that one? So look at the red stuff, okay? Those are the 3 main questions you want to ask yourself when you're drawing these things. What's your vertex? Because you got to know where to start. Which way does it open? So you're going to be drawing it going up or down. And then your slope, well, since it was negative 1, I have to go down 1 over 1, right? You're going to do that. Now notice I don't do the slope again after that. I do it once, okay? And that's it. And then I just kind of sketch my graph. So let's do one more, and then we're done. So f of x, actually this one they called it y. So we'll use y equals to 2 times x minus 4 quantity squared plus 1. Again, I'm just going to kind of draw a decent sized graph to make sure what I want to draw fits. For you guys, your graph should fit just fine. So remember, the 3 questions I want to ask myself is, what is the vertex? Which way does it open? And what is the slope? So what's my vertex?
4, 1.
4, 1. Okay. 4, 1. I'm going to go put a dot at 4, 1 right here. Which way does it open? Up. All right. It opens up. What's my slope? 2 over 1. Okay. So from my vertex, I know it opens up, so I got to go up, right? I'm going to go up twice, once over, right here. And then from the same vertex, up twice, once to the other side. Okay? And now I'm just going to draw my graph. Again, make sure it's curving. Don't make it straight lines. Okay? There you go. Kind of looks like a little reindeer, right? Sort of. So, that's it. That's what the first 8 problems of graphing look like. You're just basically going to give them the vertex, which does it open, what's the slope, and then just sketch it.